All right, General Electric Dash Series 7 instructions control equipment. All right, introduction, master controller. Description, mechanical interlocking, inspection, maintenance, reverser. Description, lubrication, inspection, maintenance, repairs on locomotive magnetic valves, brake switching. Description, lubrication, inspection, maintenance, repairs on locomotive interlocking contacts, main contacts, contact fingers, drive mechanisms, magnetic valves, power rectifier panel. Description, cleaning, troubleshooting, voltage regulator panel. Description, operation, maintenance, CMR wheel slip panel. Description, operation, maintenance, constant horsepower excitation control. Constant horsepower excitation, current excitation panel. Description, principal, system operation, monitoring, dynamic braking, maintenance, qualification for service. Speed event panel, description card, description, maintenance, operation, troubleshooting, and testing, adjustment, and annunciator panel, description, and maintenance. Figure 3-1, typical KC108 master control with braking handle, dynamic braking handle, reverse handle, and throttle handle. Introduction. This section includes information about the control of the equipment for the Series 7 locomotive. The control equipment consists of the device and panels provided with the means for the control of the equipment. Master control. The type of the CK108 master control, three-handled manually operated setup switch with which the operator can control the direction, speed, and if equipped with the dynamic braking output. Locomotive figure 3-1. The controller of throttling handles, reverser bottom handle determines the direction of locomotive movement for reverser off, forward handle move with the throttle idle and the braking handle off. Throttle mid position. Control speed with the diesel engine shutdown, idle engine idle in 8 notches. Movement of the handle shutdown position to the idle, causing all the engines to consist of the shutdown for emergency use only. Braking upper position. If equipped with the determining dynamic braking setup output with the offset off and setup position braking and braking sector. Each handle open to close the cam operated contacts. Mechanical interlocking between the handles prevents the improper operation of any handle. Mechanical interlocking reverser handle. The handle is removed with the control locked up. Neither the brake handle nor the throttle handle can then be moved. The lockup of the throttle handle is idle position. Only if the reverser handle is inserted can the throttle handle be advanced through full engine speed range. The reverser handle cannot be moved from forward or reverse when the throttle handle is in the notch 1 position or higher. Reverse handle cannot be moved from the forward or reverse when the braking handle is to set up or braking only apply if the braking is included. Throttle handle. This handle can be moved with the notch 1 higher if the brake handle is advanced to set up by the braking position. The throttle handle can be placed in the emergency shutdown position under any operation condition except when the reverser handle is removed. The throttle handle grip must be pulled outward with the compression spring to move the idle to shutdown position. Reverse handle must be inserted. Brake handle. The handle cannot be removed from when the reverse handle is in the off position. It cannot be moved when the reverse handle is in the off or center position. It must either be in forward or reverse. The throttle handle in idle or shutdown position. Braking handle cannot be advanced with dynamic braking when the throttle handle is in advanced notch 1 and 8, between notches 1 and 8, and the reverse handle is off center. Data, contact finger, throttle, brake, reverse. Overall travel in inches. Throttle 332s to 432s for an inch. Brake 332s to 432 inch. Reverser 332 to 432 inch. Reverser. Tip, brake, throttle. In inches. 1132s to 1332s for an inch. Brake 1132s to 1332s. The reverser 1132s to 1332s for an inch. Tip pressure pound. Throttle 3/4 to 1. Brake 3/4 to 1. Reverser 3/4 to 1 pound. Inspection, maintenance, periodic. The control stand cover over the back of the control stand should be removed with the following inspection made. With the following contact must be obtained on all sets for the contact figures. Examine the common surface for burning wear. Replace badly worn, burned, or pitted contacts. Contacts may be filled smooth with a fine file. Do not use sandpaper or emery cloth. Contact tip pressure is 4 for the compression spring applied with the keep of the contact finger against stationary contact. Compare with the contact tip pressure for the valves. Given the data section, measure the pressure as follows. Use the spring scale with a hook which can be inserted with the contact loop. Figure 3-2. Figure 3-2 shows the K1008 finger tip and contact relay. One is the finger block. 2 is the finger block. 3 is the finger. 3 is the finger ASM contact. 4 is the contact ASM. 5 is the terminal. 6 is the screw. 7 is the washer. 8 is the lock washer. 9 is a screw. Insert the strip paper between the stationary contact and the movable finger. Pull on the spring scale until the finger separates sufficiently to allow the paper to be removed. Observe the scale value at this time. This should agree with the values given in the data section. If it does not, the contact should be repaired or replaced. 4. Examine all the wiring and loose connections. Break with the insulation. Replace the damaged wiring. Check the handle movement of the binding. Incorrect lines or locking between the handles. Refer to Figure 3.3 with the maintenance for the controller lighting circuit. The voltage should be in 6 to 8 volts at the light socket with the play with the number 444 pin type pilot lamp. Remove the 2 screw with the indicating strip involved with the slipping of the short piece. Suitable small holes overlap to remove. To install new lap is suggested. Caution: remove and replace one of the indicating stripes at the time to prevent possible interchange over the strips. Check the braking pentameter when equipped for the open short circuit. The resistance should measure 45 to 55 ohms. Alright, Figure 3.3 shows the schematic lighting circuit. And in the dash block, you see the scale plate lighting dynamic braking. You have a generator number 4 lamps, scale pilot light throttle, white and black, resistor 1 and 2, 300 ohms to 50 watts, and W, G, and M connection points. To place the finger, move the back cover over the operator stand and give the back of the controller. Move the screws, lock washer, back lock washer, and washer finger block to be replaced. Move the terminal 5, the lead attached. Place one side if the terminal to be replaced with a wire. Figure 3.4 show the rear view of the controller. Brake pentameter, segment gear, engine, finger block, brake handle, front plate, finger contact, top plate, terminal lamp resistor. Move the finger assembly 3 with the controller. Place the new finger assembly 3 in the position of the finger block. 6 insert with the 6 screw 6, lock washer 8, the washer 7 with the terminal 5 through the mounting holes with the finger assembly 3 with the screw to the finger block 1. Repeat steps 1 through 6 for each finger assembling being replaced. To replace the contact, remove the screws 9, lock washers 8, washer 7, the finger block 2. Move the terminal 5 with the lead attachment, replace one side. If the terminal is replaced, can move with the wire. Move the contact 4 with the controller. Insert the screws 9, lock washers 8, washer 7 from the terminal. New contact 4. Secure the assembly finger block with the 2 with the screws 9. Repeat steps 1 through 4 for each for the contact to replace. It's suggested that they be done one at a time so the circuits are not to be altered. Place the cover over the operator's stand. Description: type DP26 reverser is electrically controlled with a pneumatic switch with the control connect to the traction motor field with the forward or reverse motor armature rotation. The reverse lever is on the controller to move the either forward or reverse position and corresponding to the contact between the reverse lever of the globe of the energizer, either forward or reverse magnet. The magnet valve in turn activate the main contact switch of the traction motor to correspond with the position of the reverse lever. The reverser consists of the following main parts: for the contacts, interlocking magnet valve, the air cylinder's main parts, along with the components that are mounted on the metal frame legs, made special mounting of the feet to the bolt reverser in position. Figure 3.5 shows the 17DP26A1 reverser. Starting at the bottom, you see the rod end frame insulation sleeve, terminal block, cylinder end cap, magnetic valve, end frame cylinder, pawl spring, air supply, manual operating lever, segment gear or pawl assembly, interlocking stationary movable insulation spacer, contact finger removable point, stationary contact center, station contact side. Refer to Figure 3.5 for the location and principal parts of Figure 2.3.6 for the typical contact number of the interlocking main contact terminals. Lubrication. Apply simple drop of the D50 E5B oil with the oil surface with a bearing, bushing, grease the surface with the bolt ball rollers and segment gear of the D6A26C5. Inspection maintenance. Preliminary inspection. Check all the bolted connections for the proper tightness. Torque the 5/16 and 18 threads on bolts to the 12 foot, 14 pounds, 3/8 and 16 thread bolts to 21 to 24 foot pounds, 1.5, 13 thread bolts to 40, 45 foot pounds. Check the condition of isolated rods, insulated sleeves, support blocks. Make the replacement any of the rods and sleeves and bolts that cracked and burned and broken. Main contacts and contact fingers. Mark for the replacement any type of successfully worn, burn, or pitted. Tips pitted less than 1/32 of an inch may be dressed with a fine flat file. Observe the contact, make sure the brake overall travel in line properly. Our typical reverser contact numbering front view forward position. The magnetic valve of the forward and reverse. Your control interlockings 1 through 4 relays, and then you have the main contacts with the relays notches 1 through 4, 5, 6, 7, and of course, and then 6 to 7, and 5 to 8, 9 to 4, 3 to 10, 11, 2 to 11, 1 to 12. Interlocking contacts. Marked and replacement any tips of excessive warm burner pitted drive mechanism, and inspect the operation of the reverser with the control air supply, the depressing armature with both magnet valves one at a time. Sluggish operation may indicate sticking of the leaking magnet valve, leaking piston packing. Figure 3/7 is the measurement of force required to manually operate the reverser. You have a 45-degree angle with a 20-22 45-degree angle, 1.5 inch radius maximum wear allowance between the C, A, B, C, and D, in the center. Pawl rollers pressure against the star wheel maintain tension spring. Torque is obtained with a multiplying length of the level arm force on the rod, length of the lever over the arm, spring force of the ready within the pull of the perpendicular rod. Direction of rotation: north to end to A. And N to C, 200 inches in pound torque. C to D and A to B, 540 inches in pound of torque. If the packing shows sign of aware of the deterioration, blow by as if the replace of the packing, check with the air leaks, hose with the pipe connection with the magnetic valve of the air engine cylinders with the soapy solution, use the normal locomotive control air pressure, reduce the control air pressure to 45 psi, check with the proper operation of the reverser in both directions. With the control air shut off, check the torque with the required for the operate the reverser manual, insert with the rod lever, the hole, the pulling, the spring scale, and the known distance, measure the torque for from neutral position over the start switch. Star wheel notch in both directions. Figure 3/7. Check the star wheel with the pawl hold on the contact finger with the completely unwiping with the air pressure shut off. Main contact should also close with 1/8 of an inch of each of the other both positions. Also check the main contacts closed before opening and after the interlocking contacts. Repairs on locomotives. Anticipated some of the bus bars and cables must be disconnected to remove the reverser available for the repair. Note that the right-hand door post of the main control compartment is removable to better access the reverser area. Caution: all bus bar cables and contacts mounting rods must be marked with the proper replacement before removal of the reverser to prevent missile application. Subsequent electrical damage care must be exercised with the handling and restoring the bus board to prevent bending of the copper. Note: when the aluminum cables of bus bars are connected with the copper terminal blocks, the special instructions application joint compound must be followed. Refer to overall maintenance manual. Interlocking contacts: remove and replace any damaged parts. Main contacts, stationary contacts inside and out. Cast type: remove the 1.5 inch bolt holding the insulated support rod with the damaged contact at the end of the frames. 2. Remove the rod and the stationary contact. 3. Slide the insulator spacer station contact with the insulated rod. Repair and replace with the contacts. Reassemble the inverse order. Form type: remove the clamp bolt with the metal spacer with the damaged space. Stationary contact: remove the contact with the insulated rod. Repair and replace the damaged contact. 4. Reassemble. Reverse order. Contact finger: remove the 2 bolts holding the terminal block with a flexible shunt to the insulated support rod. Figure 3/8 and 3/9. Remove the nut holding and retaining plate with the contact finger bolt block support studs. Remove the repair and replace with the contact finger assembly. 4. Reassembly in reverse order. Figure 3/8 shows the lower end of the frame partial assembly with the contact support parts. Contact finger support block. Check to see if the insulated rod's insulated sleeves have been burned or run a crack. Contact finger isolated rod. Put 5/16 of an inch washer head to adjust the finger pressure. Flexible shunt. Terminal block bolt mounting bolts. Drive mechanism: normally a damaged segment of the gear support with the assembly can be disassembled and removed by removing the 2 ball spring with the 4 3/8 inch mounting bolt that can be unbolted with the replace with the repair and the damage of the part with the reassembled reverse order. Figure 3/10. Caution: after reassembly, check all the connection retaining bolt for the tightness. Check the connection insulated contact for the proper location shown with the locomotive diagrams. If the rods are not keyed to prevent inverting them, improper assembly can result in damage to the electrical equipment. The magnet valves. Description: the MV38 magnet valve is used with the on the DP26 reverser. The valves can control the airflow over the air cylinders, which in turn control the action of the reverser. The magnet valve with the flowing of the main parts frame with the coil, armature valve, body valve, stem, terminals. These main parts are assembled with the others to make the complete valve assembly shown in Figure 311 312. Or Figure 311-39, exploded view with the self-aligning standard finger assemblies. On the left, you see the compression spring, the retaining plate spring seat, the spring guides, and the braid shunt with the mounting bolts and the terminal block. On the standard type, you see the retaining plate spring seat, the compression spring, the spring post, the braid shunt, the mounting bolts, and the terminal block. In Figure 310, exploded view of the drive mechanisms parts. The cylinder end frame, the piston cylinder, the operating lever, the cotter pin, segment gear, pulse support, star wheel, pulse spring, chalk, pulse, snap ring. Magnetic valve data. The table 3.1 shows the coil resistance volts continue for the amps required to operate the various forms of MV38 magnet valves. Figure 3.11 shows the MV38 magnet valve. The valve body frame, retaining ring, core, coil, terminals, valve stem, armature guide. Figure 3.13 shows a sectional view with the magnetic valve. 1 is the armature, 2 is the armature guide. 3 is the screw, 4 is the frame, 5 is the valve body, 6 is the inlet valve, 7 is the spring, 8 is the gasket, 9 is the cap plug, 10 is the screw, 11 is the exhaust valve stem, 12 the retaining ring, 13 friction washer, 14 washer, 15 valve coil, 16 terminal, 17 valve seat. Table 3.1 type of the MV38 magnet valve. Coil form 1, resistance in ohms at 25 degrees Celsius, 336 volts, continuous 88 amps to operate at 90 psi, 108 thousandths. Coil form 128 ohms, volts 55, 181 thousandths at 90 psi. Coil form 6, 775 ohms, resistance and 135 volts and continuous, 69 thousandths at 90 amps at 90 psi. 8 has 3080 resistance ohms, volts continuous, 270, 36 thousandths amps operate at 90 psi. Coil form 12, 84.9 resistance ohms, volts continuous, 44.6, 206 thousandths to operate at 90 psi. Amps required to operate at 70 psi are 91% of the amps required to operate at 90 psi. Amps required to operate with the mounted upside down increase 15%. Application at more than 90% psi is practical only under special conditions. Inspection maintenance. The following procedure will assist the inspection maintenance of the magnet valve figure for the 313. Test the magnet valve operation depressing the armature top of the magnet. If the valve sticks, it must be cleaned and refer to the applicable maintenance manual. Figure 3.13 valve travel. Show the valve engine energized with the top surface of the valve seat. 52 thousandths of an inch plus or minus 3 thousandths of an inch. Valve de-energized bottom surface valve seat. 104 thousandths of an inch to plus or minus 5 thousandths of an inch. To test for leaks, apply soapy water to the pipe of the connection exhaust port while the air pressure is on the valve to tighten all the leak connections. A small amount of leakage through the exhaust port, a gap acceptable with the locomotive leg down. The test can still remain in limit. Successful leakage is found. Disassemble the valve. Cleaning refer to the applicable maintenance manual. Alright, your brake switch. Description. The type G19 brake switch is electrically controlled power switch with a connect with the braking grid with a cuff with the traction motor, armature set with up the power with a circle with the dynamic braking with the locomotive. When the selected brake hand with the control is moved with the braking position, electrical actuated to magnet with the valves are supplied with the controlled air with the position air engine cut with the contact the braking switch. Go over the two position. Refer to Figure 3.14 location principal parts and Figure 3.15 the typical contact numbering with the interlocking main contact terminals. Lubrication. Apply several drops of the D50E5B oil to the surface of each of the bearing bushing, grade the surface of both of the pawl rollers and segment gear of the D6A2C5. Figure 3.14, the 17 GPL 19L1 brake switch, starting on the bottom rod end frame, terminal block shunt, cylinder end, air engine, hidden cylinder end cap, magnet valve, pawl, air springs, air supply segment, gear top, pawl assembly, manual operating lever hole, can control the voltage interlocking, high voltage interlocking, contact finger removable, contact right side, stationary contact center, insulation spacer, insulating sleeve. Figure 315 typical contact numbers on the braking switch view at the front. Shows the magnet valves in M and B, the braking setup inner contacts, and the mounting braking inner contacts. On the left side, you have on the right, and then the high voltage interlocking contacts, which is a double push button, 10 and one across the motor braking interlockings. Motor braking interlockings 1, 2, 3, 4, and 5. Interlocking going to 2 and 9, 3 and 8, 4 and 7, and 5 and 6 main contacts. Inspection and maintenance. Preliminary inspection. Check all the bolts and connect with the proper type with the torque with the 5/16 with an 8-inch thread, 18 threads bolt with a 12 and 1/4 inch for the foot-pounds, a 3/8 inch 16 threads bolt to 21 24 foot-pounds inch, 1.5 inch 13 thread bolt with the 40 to 45 pounds of torque. Check with the insulated rods with the insulated sleeve with the support block for the mark with the replacement ending for the rod sleeve with the blocks are cracked or broken and burned or broken. Main contacts and contact figures make the replacement any type of excessive worn, burn, or pitted less than 1/32 inch may be drafted with the fine flat file. Observe the contacts make for the brake overall travel in line properly. Interlocking contacts make the replacement any type of excessively worn or burned or pitted driving mechanism. Inspect the operation of the switch. Control air supply with the depressing armature for the both the magnet valves. One at a time. Sluggish operation may indicate stick with them leaking with the magnet valves. 2. Leaking piston packing. If the packing show for the sign with aware of the deterioration of the blow-by exists, replace with the packing. Check air leak for the at the hose of the pipe with the connection with the magnet valve with the air engine with the cylinder with the soapy solution. Use normal locomotive control air pressure. Reduce the control air pressure for the 45 psi. Check with the proper operation made. Braking switch for the both directions. Control the air shut off the check with the torque with figure 316 with the required to operate the braking switch manually. Insert with the rod lever the hole with the pulling of the spring with the scale with the known distance. Measure the torque from the neutral position over the star wheel notches in both directions. Check with the star wheel and pawl hole with the contact finger for the complete unwiping. With the air pressure shut off, main contact should also close within 1/8 of an inch over the other both positions. Also, take the main contacts closed before and open after interlocking contacts. Figure 316 measurement of the force required to manually operate the brake switch. In the center, you have the neutral position with the pawl roll pressure against the star wheel, maintain the tension spring. Then A and C to the left, C and D to the left of the neutral position with a 22 to 45 degree angle. A and B to 22 to 45 degree angle. 1.5 inch radius wearing allowance. Length of the arm, level of the arm, the torque distance, multiplying level of the level arm times the force on the rod. Spring balance force to read the line with a pull perpendicular hold. Neutral to A, 200 pounds in pounds. Neutral to C, 200 pounds in inches in pork pounds. 200 inches in pounds. C and D and A and B to 540 inches in pounds. Repairs on locomotive anticipated with the sum of the bus bars and the cables must be disconnected to make the brake switching available. The repair note the right-hand door must be in the main control compartment with the removal of the letter X for the braking switching area. Connect with all the bus bar cable. The contact mounting rods must be marked with the proper replacement before the removal of the braking switch to prevent missupply application. Subsequent electrical damage care must be exercised with the handling the short bus, storing the bus bar to prevent ending with the copper. Note when the aluminum cables and or bus bars are connected with the copper terminals, special instructions to application joint compound must be followed to refer to the overall maintenance manual. Interlocking contacts. Remove and replace any damaged parts. Main contacts. Stationary contacts inside and out. Cast type. Remove the 1.5 inch bolt holding the insulated support rod with the damaged contacts at the end of the frame. Remove the rod. Stationary contacts. Slide the insulator space of the stationary contacts from the insulated rod. Repair the plate for the contacts. Reassemble in reverse order. Figure 317 shows the lower end of the frame partial assembly with the contact support parts. Alright, terminal blocking, mounting bolts, flexible shunt part, 5 securing the washer, adjusting the finger with the insulated rod, contact finger, check to see if the insulated with the rod's insulated sleeve have been burned or perhaps are broken, contact finger support block. Form type, remove the clamp bolt, metal space with the damaged stationary contact, remove the contact insulated rod, replace with the damaged contact, reassemble the reverse order, contact fingers, remove the two bolts with holding the terminal block and the flexible shunt insulated support rod, see figure 317, 318. 318, exploded view with the standard self-aligning finger assemblies, terminal block mounting bolts, braided shunt, spring guides, compression springs, and retaining spring seat with the self-aligned type, standard type, retaining place, spring seat, compression spring, spring post, braided shunt, mounting bolts, and terminal block. Alright, 2. Remove the net holding retaining plate with a contact finger block with support. So, remove the plate with this contact finger assembly. Replace it. Reassemble in reverse order. The drive mechanism. Normally damaged segment of the gear support with assembly. Disassemble. Remove the 2 ball spring so that there 4 3/8 of an inch mounting bolts can be unbolted. Replace or repair any of the damaged parts of the reassembly in reverse order. Figure 319. After check with caution. After assembly, check all the and retaining bolts for the tightness. Check for the connection, insulated contact proper location. Shown with the locomotive diagram as if the rod and ends are now keyed. To prevent inverting with them, improper assembly can be result in damage to electrical equipment. Magnet valve description: the type MV38 magnet valves are used on the GP19. These valves control the airflow of the air cylinder switch, with in turn control the action of the brake switching. Figure 319 exploded view with the drive mechanism, cylinder frame, end frame, piston, cylinder, operating lever, segment gear, control, cotter pin, pawl support, star wheel, pawl springs, check pawls, and snap ring. Figure 320, magnetic valve, MV38 magnetic valve, valve body frame, coil core, retaining ring, terminal, valve stem, armature guide. A magnetic valve, following main parts of the frame, coil, armature, valve body, valve stem, valves, terminals. These main parts are assembled other than make the complete valve assembly, shown in figure 320 and 321. Figure 321 sectional view with a magnetic valve. 1 is the armature, 2 is the armature guide, 3 the screw for the frame, 5 the valve body, 6 the inlet valve, 7 the spring, 8 the gasket, 9 the cap plug, 10 the screw, 11 the exhaust valve stem, 12 the retaining ring, 13 the friction washer, 14 the washer, 15 the valve cooler, valve coil, 16 terminal, 17 valve seat. Magnetic valve table 3-2 show the coil resistant with the volts continue for the amps required to operate the various forms of the MV38 magnet valve. Coil form 1, 336 ohms, 88 volts, 108,000 amps, and 90 psi. 2, coil form 2, 128 ohms, 35 volts, 181,000 amps at thousands of an amp at 90 psi. 8, 6, 775 ohms, 135 amps, 135 volts, continuous, 69,000 amps to operate at 90 psi. 8, coil form 3080 ohms, 270 volts, continuous, 36,000 of an amp to operate at 90 psi. 12, coil form 84.9 ohms, 444.6 volts, and 206 thousandths of an amp at 90 psi. Amps required to operate at 70 psi are at 91% of the amps required to operate at 90 psi. Amps are required to operate with the mounted upside down, increased 15%. Application more than 90 psi with a practical under special conditions. Inspection maintenance. The following procedure will assist in inspection maintenance with the magnet valve 321, 322. The magnet valve operation, depressing the armature for the top of the magnet with the valve 6 must be cleaned and refer to the applicable maintenance manual. Test the leaks of apply with soapy water with the pipe with the connection exhaust port while the air pressure is on. Figure 322 valve trail. 52,000 of an inch plus or minus 3,000 of an inch top surface of the valve seat, valve energized, valve de-energized bottom surface of the valve seat, 104,000 of an inch plus or minus 5,000 of an inch. Alright, figure 323 17FM307B1 power rectifier panel. The valve, tighten all the leakage connections. A small amount of leakage with the exhaust port with an acceptable locomotive leak down test can still remain limited. If the excessive leakage is found, disassemble the valve for cleaning. Refer to the applicable maintenance manual. Or your power rectifier panel. Description: the principal part of the type of the FM307. The power rectifier parts are included with the high current with the silicone rectifier diodes, heatsink, resistor capacitors, and associated hardware. Figure 323 and Figure 324. Figure 324 shows the form A1 rectifier panel, diodes in all position, diodes with red pigtails, and diodes with black pigtails. Figure 325 typical sequence circuit schematic. You have the DC bus bar with a ribbon resistor, the O3 C1 through C2 3 4 04 03 C3 D3 AC bus bar, DC positive bus bar. Electrically formed FM301 panel have the number of the circuit with the AC negative of the AC from the AC to the DC positive bus bar shown figure 325 326 on table 3.3 to give the various model differences. Alright, the FM307 the models A1, A2, B1, B2, C1, C2, A1, A2, 7 parallel, no number of parallel circuits. an X for the provided temperature sensor, 11 for the negative diodes, and 1 for the positive diodes. B models 6 parallels, number of pixels, curve of the X for the positive temperature sensor, 11 negative diodes, 1 positive diode. C1 number of 5 parallel circuits, positive temperature sensor, 11 diodes, and positive diodes. Figure 326 show the typical schematic of the panel. Show the bus bar, the DC negative of the AC bus bar, and the DC positive negative bus bar, and the models. Figure 326, 27, the comparison of the negative positive base diode of the panel. Use the two different types of diodes. Simplify the circuit with the positive, the red 4.5 inch pigtail, the negative black, and 5.5 inch pigtail type. Figure 327 with the comparison of the two types. Figure 327 with the comparison of negative base diode, positive base diode, red pigtail, but negative base diode, black pigtail. Alright, the form of the A power rectifier panel is contained with the several parallel circuit having 28 high current with 1200 volt silicone rectifiers at 1.5 MFD capacitor connected with the parallel across the rectifier. Figure 324, the panel contains 4 separate heat sinking strips, 14 load sharing ribbon resistors. Left heat sink strips on all panels prepared with a single sensing element monitoring with the panel temperature with the form L and form 1 panels have the cover plate with the sensor location, while forms 2 and 3 have sensing elements installed. The terminal strips are also provided with near the sensing element in the lower left corner with the form 2 and 3 panels. Figure 328 external wiring form 4 panel of the telltale resistor to give the visual indication of the component failure. Figure 329, figure 330. Figure 328 over temperature censoring in the terminal strip. The 17FM307 panel terminal strip heat sinking diode over temperature sensor capacitor diode. Figure 329 rectifier panel showing early telltale resistor solder to the main mounting strip. The strip of the resistors. Form B panels contain 6 parallel circuits having 24 high currents with 1200 volts of silicone rectifier having the capacitor connected with the panel parallel across each rectifier. These panels contain 4 separate heat sinking strips with 12 loading sharing ribbons and resistors. Schematically form the B with the one less string with the components of the form A panels. Figure 330 partial schematic diagram showing connection with the telltale resistor between adjacent circuits. Alright, you have your black pigtail diode, red pigtail diode, resistor 5, resistor 6, thermostat, temperature indicating resistor, negative external connection, ribbon resistor, capacitors, an AC external connection. Form C panel contains the 5 parallel circuit having the 20 current, high current amps, 1200 volts. The silicone rectifier with the capacitor connected with the parallel across each of the rectifier. The panel contains 4 separate heat sinking strip with the 10 load sharing ribbon resistors. Schematically form C load 2 less string components with the form A panels. Diodes must be checked with periodically per established schedule. With the failed diodes must be detected and replaced to prevent overloading the remaining diodes in parallel circuit. The interruption of the circuit for the ring the circuit that share with the same load to the cause of the high average currents associated to increase the operating temperature of the ultimate with the burn up of the panel with the possible single phase over the alternator. Your special tool equipment: diode, wrench, torque wrench, sealer, Simpson 260 analyzer equipment, the DV Vilbus type DG D520 cleaning gun, HM521 spray gun, 6 cleaning solvent, chloroethanol, chlorethane, NU diode testing unit. Alright, cleaning. Blow out any of the dirt accumulation with a dry compressed shop air with the fail to remove the dirt. Continue with the follow the cleaning method. Warning: when you with the compressed air for the cleaning the purpose of the environmental potential hazard personnel immediate with the area created to prevent the physical injury, flying debris, observe all the road OSHA safety regulations. Use a spray brand such as the Devilius type DGD520 cleaning gun, the A or the HM52-1 oil spray gun. The two guns differ, with the DGD520 gun with a siphon hose and insert with a separate container of solvent, while the HM521 gun has attached quart container, not quite enough to clean one panel, but if the DGD520 spray gun is used with the solvent, can be siphoned directly from the container in the open just to be large enough to permit inserting with a siphon hose if provided. Be sure that the local equipment to be cleaned with a well ventilated with a cleaning solvent and chloroethane and an NU high voltage degreasing agent. Warning: solvent should be used within well ventilated air with a face mask to protect against breathing and to remove much of the vapor that will also avoid skin contact with the grease or well dried up natural skin oils. With the power plant shut down, remove the covers of the rectifier panel, spray the diode solvent, making sure that the soak with the ceramic sleeve portion, and repeat the spray operation several times. Surface appears dry after each application period. Remove the dirt with a clean cloth, and if it's still dirty, repeat the spraying with the wiping process. Troubleshooting: the early detection and replacement of the bad rectifying diodes, open or short, will prevent the catastrophic damage caused by the major rectifier panel failure. Periodically remove the cover to inspect the panel with the components, wiring cables for the damage, overheating, inspect the panel for the dirt accumulation, view the panel failed components, loose or broken connections, check with the color of each of the telltale resistors. If one or more of the darkened, check with the failed power diodes, the capacitors. Panel replacement: the power plant shut down, remove the bus bar and cable connection with the damaged panel. If the hatch is provided over the rectifier panel, leave the crane to lift out the damaged unit of the panel with the weigh out to 126 pounds each. Reverse the procedure, install the new panel. Be sure to check the cable connected to both ends of the AC cable. The possible damage signs of overheating trouble here could result in the single phasing of the alternator. Even if this rectifier panel were working, cover the loss of power will initiate the heavy torsional vibration of the engine, alternator, and all the equipment mechanically connected to the alternator rotor. This includes the blow-by air compressor and radiator fan. Or you're bolting bus bar or cable to the bus bar. There's always a slightly gap between the mating of the surface. It's important to apply the thin coat of the joint compound TBM53GE part 41A204944P1 to both surfaces before bolting them together. This will prevent dampness, moisture for the accumulating of the joint, with preventing the subsequent corrosive action, high resistance oxidation, loose connections at the junction. Also, the compound contains fine particles with a high conductivity metal with a bite and the contact surface making low resistant joint. Bolt torquing: proper torquing with the bolts is very important. See the table 3-4 with the torque value for the over torqued joint with the trouble that is just as untorqued joint with the proper reassemble the plate washer. Flat washer with bolts is very important, properly distributed with the pressure. Table 3-4 with the torque value: 5/16 of an inch to 18 threads, 12 to 14 pounds of torque. 3 to 8 of an inch, 16 threads, 21 to 24 pounds of torque. 1.5, 13 threads, 40 to 45 pounds of torque. Rectifier diode. Warning: electrical shock can cause a serious fatal injury. To avoid such injury, personnel should take with the observe all the precautions. Quickly check for the rectifier diodes made accomplished without disconnection. Use the test unit schematic, which was shown in the figure 331, completely the instructions of the building. Using the unit can be obtained with the General Electric locomotive representative. An alternate method of tracking the individual rectifiers can be done with the setup of the checking of the individual rectifiers can be done with the setting up the shown in figure 332. The braided terminal must be disconnected to make this test. Caution: make the following resistance check with the power removed from the panel to prevent the damage for the analyzer. Panel diodes can be checked for opening with the short with the condition with the measuring forward with the reverser with the rectifier analyzed, but not necessary with the disconnect with the rectifier diode with resistor capacitors. Leads for the panel circle for these check. The forward resistance check. Note the forward direction of the diode with the black pigtails is from the pigtail to the base, while the red pigtails can note the forward direction from the base to the pigtail. Figure 331 diode testing unit schematic: black lead, red lead, reverser, direction switch forward, current 1.5 watt, 500 ohm, 5000 ohm current limiting resistor, negative and positive battery array at 6 volts, battery switch, rare lantern batteries, meter calibration, pentameter rheostat at 10,000 amps, ohms at 0 to 1 and mA ammeter. Set the analyzer of the R to the 100% scale. Check the forward resistance each rectifier by placing the positive lead analyzer points indicated in the figure 326 and then with the following party. Step 1, positive A, negative B, 28 to 428. All the test limits are 280 to 44 280 to 440 ohms test limit. Step A is step 1 is A positive, B negative. Step 2 is B positive, C negative. Step 3 is C positive, D negative, and 4 is D positive, E negative. Note the braided lead of the rectifier plaque, the pigtail with positive, the red pigtail is negative. 313 silicone rectifier diode voltage schematic. 222.5 voltage battery switch, a voltmeter and for the negative rectifier black. Check for the forward resistance, grab the forward rectifier with lower string with the shown figure 326 with U with the same polarity transverse analyze the lead with the comparable to the point with the other string with the variable. Check for the each of the rectifier with the panel forward with resistance should be 280 to 440 ohms across each rectifier. Note that the forward resistance value of the rectifier not within the limits given the disconnect the rectifier with the circle to make forward with the reverser voltage check with the figure 329. Reverse check resistance check set the analyzer R to 10,000 scale. Check with the reverse resistance each rectifier to connect the analyzer for lead with the reverse polarity and 10 with step 2 under the forward resistance check for example A negative, B positive, and for the reverse resistance shown it would be 15,000 to 21 ohms. All test limits are 15,000 to 21 ohms. The step 1 is B positive to A negative. Step 2 is C positive to B negative. Step 3 is D positive, C negative. Step 4 is E positive, D negative. Check with the resistance for each of the rectifier, same manner with the forward resistance was checked. Note if the reverse resistance provided the rectifier is not within the limits given the disconnect the rectifier with the circle to make the forward and reverse voltage shown in figure 329. Your alternate diode check. The special test unit can be built with a utility to check of the rectifier panel and diodes with the disconnect from the circuit with the unit measure for the voltage drop of the diode, the energize the lantern banner, the instruct for the E within the unit with the given the same publication required for the copy of your service engineer. 4. Remove the power panel to disconnect the rectifier braid terminal. Remove the rectifier using the special cycle wrench. Figure 333. Remove the rectifying diode from the panel. Figure 333 of the torque diode within the typical panel. The torque wrench and the diode wrench replacement. Apply light film with the Dow Corning. Apply light film with the Dow Corning 340. Diode mounting phase only with the figure 334. Caution, do not apply the diode Corning 340 to the diode thread to prevent obtaining the required torque values. Play the diode in reverse order to make sure the capacitor connections are tight. Caution, when replacing the diode, locate the braid that does not touch the short against the adjacent components. Keep it as far away from all other components as possible. 334, typical application of the Dow Corning 340. Dow Corning 340 part cable capacitor wire with number 1032 screws, upper capacitor clamps. Alright, assemble the die with a torque of 25 pounds. The torque back off the 1/2 drum. Reapply the torque to 25 pounds. The torque obtain the proper electrical contact heating transfer capacitor. Check all soldered connections to the capacitor terminal for the broken connection from the open and short of the capacitor with the electrical type with the UT analyzed for the ohm scale with 0 to 10,000 greater. Check the analyzer a high resistant range for the caution to discharge the capacitor before disconnecting lead and testing an analyzer. Discharge the capacitor through 1,000 ohms resistor connected between the terminals with the obtain the full discharge shortening capacitor for the insulated jumpers. Replacement. Remove the power with the panel. Discharge the capacitor to be replaced with unsoldered wires connected to the capacitor and so with any of the resistors connected across the capacitor terminals. Loosen upper resistant clamp with removing the 1032 nuts. Washer, lock washer holding in place. Remove the capacitor. Replace the capacitor in reverse order. Resistor. Check the ribbon resistor. Loosen shorten threads. Tighten replace the defective unit. Replace the telltale resistor and then install the FM307 panel for the earlier 1977 plug into the spring clutch and the socket with the terminal strip. And the resistor can be replaced by simply pulling out the black one and inserting the new one. Alright, on an early panel, the resistor was where solid the connection of the terminal strip of the camera must be taken with replacing one of the resistors, even the low wire soldering iron and heat sink with the preventing of the premature discolorization heat sensitive tape with the new resistor tape that turns black with the temperature resistor exceeds. The replacement of the ribbon. Remove the power of the panel. Remove the clamp block assembly containing the capacitor. Remove the end of the ribbon resistor connected to the heat sink. Remove the other end of the ribbon resistor connected with the braided rectifier lead. Replace the ribbon with the resistor reverse order. Your over temperature switch sensor figure 328 and 329 should be checked with annually proper operation. Recommended removal of sensor testing in the oven to prove the circuit with opens with the temperature exceeds 94 to 104 degrees Celsius or 200 to 220 degrees Fahrenheit. Alright, voltage regulator panel. Description. All form of the type of the FH23 voltage regulator panel have the voltage regulator module with the basic compartment that keep the locomotive battery properly charged with the control of the output and with the self-excited auxiliary DC generator with the regulator sensed with the auxiliary generator output adjust the field control current to maintain 74 volt DC positive under the various condition load engine and RPM figure 332, 335. Components of part of the voltage regulator, some of the printed circuit module not a removable card in the bracket and insulated with the base along with resistor, diode, transistor, capacitors. Test points monitor, light, fine voltage adjustment pentameter of the circuit breaker with the 7-pin connected with the external condition for the made with all the mounted front panel with the A1 with the using the 5 amp circuit breaker with the section cover with the basic of the 17 FH23A1 panel with the voltage regulator function additional protection. Figure 35 typical FH panel installation module over voltage limited protection. Other forms of the panel included one but additional function negative current limited protection, positive current limited protection. Each of these functions assembled on the individual module. Several modules are mounted on the panel, providing various forms of field FH23 voltage regulator. See table 3-4. Panel forms of the protected forms. Protected function module position of mode A1, B1, C1, D1, 1, D1, D2, E1, EF1, 2. All apply for the voltage regulator. For the negative current limit, the position modulate 2 starts with B1 and F1 and F2. Positive current limit for the C1 and E1, and over voltage as D1, 2, D1, D2, E1, and F1, F2. The voltage regulator with additional protection made module will protect the control circuit of the locomotive with the battery against excessive voltage due to the runaway failure of the regulator. The schematic diagram of the model of the FH23 voltage regulator is shown in figure 336. The 17 FH23D1 module differs from the 17 FH23D2. The module with having circuit breaker the 23CB1 auxiliary generator field circuit, which rates 5.0 amps, with the D2 module rates at 7.5 amps. Operation. The battery voltage monitored with the terminal B and D to D on the module with the voltage applied across the resistance network of the R2, R3, P1, and R4. When the battery voltage reaches the preset voltage threshold, normally set with the 85 volts DC, the transistor Q1 begins to conduct with allowing the relay RL1 to pick up the supply of the battery voltage terminal E through the two pairs of the relay contacts in series. Create the arc gap of the relay with the contacts external relay with the LV66 type that can be used to interrupt the auxiliary generator shunt field circuit. Circuit can be tested and pressing with the push button with the switch with the face panel with the sense of the circuit is brought out through the terminal C and F. Alright, your maintenance. Periodically examine the panel and perform the following operations. Inspect the panel for the damaged and discolored components to replace all faulty parts. Warning, when using compressed air with the air cleaning purpose of the environmental protection, potential hazard for the personnel with immediate air is created to prevent the physical injury, flying debris. Observe all railroad OSHA safety regulations. Blow out dirt and dirt with clean, dry compressed air. Check the loose terminal connections and then broken the damaged wire, tighten and replace the necessary. Shift the module to secure the fasten in place. The CMR wheel slip panel. I'm going to cut the tape and we'll come back to do the rest of the half.